class 25 UJT firing circuit for SCR. AC supply, diode, current limiting resistor for Zener diode, and UJT in relaxation oscillator mode. So you have here AC supply. After diode you get only positive half cycles. Zener diode will make the voltage constant after its breakdown voltage, and here this is actually AC wave. Actually it will be like this, AC wave, and then VZ constant, and then again AC. So after the breakdown voltage of the Zener diode, the voltage will remain constant across the Zener diode. Without Zener diode also this circuit will work, but we like to have the voltage across the UJT circuit constant most of the duration. That is why you use Zener diode. Without Zener diode also this will work. Now when this voltage is applied to the UJT circuit, Zener diode voltage will be applied to the UJT circuit. So capacitor will charge from valley point to peak point, valley point to peak point, valley point, peak point, like that it will go. In the beginning when you switch on, the capacitor will charge from 0, but once the operation begins, it will be from valley point to peak point. Here the scale is not correct. If this is 10 volt, then this will be only around 6 volts, because intrinsic standoff ratio is around 60 to 70%. So this will be around 6 to 7 volts only. This will be around 1 or 2 volt valley point. Beyond the valley point, SCR will again block, and then again it will start charging. If there is some supply, continuous supply here, it will again go on charging. Now let us see the operation. When the capacitor voltage reaches the peak point of UJT, UJT will conduct, means junction E to B1 will break down. So capacitor will discharge like this. Primary of the pulse transformer will get a pulse, which will be reflected in the secondary. So secondary has now a pulse which can be applied to gate. The power circuit is not shown, load is not shown. You can give to gate. If you want to show that, in your syllabus it is not shown, but for you to understand, see, from the power supply you have SCR and load. Give this gate to gate terminal, give this cathode to cathode terminal. A diode is usually put to prevent any negative gate current in case of surges. Because of the because of the pulse transformer, the firing circuit is isolated from the power circuit. The gate and cathode terminals of the SCR has no physical connection with these components, only the pulse transformer and diode. Two secondaries are given here in case you have to fire more than one SCRs at the same time. Say series, parallel combinations, many things are there. Here, okay, if you don't want pulse transformer, you can also put the same thing, but you can fire only one SCR. See, at the output of UJT, we have RB1, and we give it to the gate and cathode, but there will be no isolation. Now the cathode of SCR is touching the other components too. Here you will have capacitor, etc., everything. This is called as synchronized firing circuit. The synchronization, the word is understood, even if you don't write, sorry, even if it is not said there, it's understood, because in case of AC, synchronization is a must. Means the firing circuit or the instant of firing calculation is done with respect to the zero crossing of the AC supply. This is zero crossing towards positive, zero crossing towards negative. So charging of capacitor should begin with respect to the zero crossing of the AC supply. So that condition is fulfilled here. That is why this is called as synchronized UJT firing circuit for half wave or half wave control. Another thing is, you may get more than one pulses in one half cycle. This is zener voltage. The capacitor charges. This is valley point, peak point of UJT. Charges, discharges, charges, discharges. See, if we keep R high, you may get only one pulse in a positive half cycle. If you keep R less, you will get this so many times. Whatever it is, SCR needs only one pulse, that is from top to bottom. Only one pulse to fire. Once SCR fires, the SCR load will be on from this instant till the end of positive half cycle due to latching property. So whether you get more than one pulse or one pulse, it is immaterial. When you will get the first pulse, that is the triggering instant of SCR. So alpha will be calculated with respect to this point. In this 180 degrees, it is this point. How much is this angle? That is alpha. Initially capacitor will charge from 0 at the first instant when you switch on, but after that it is from valley point to peak point. Hence it is a gap is shown here. Here gap is not shown because this is the voltage shown here is with respect to the pulse transformer output. That will become 0 as soon as it is discharged, or it will become 0, whereas the capacitor voltage will not become 0, because when the capacitor voltage reaches the valley point, UJT conduction stops because of lack of charge carriers. So that all things are not necessary to you in this